Hi, my name is Meaghan Keane, and I worked on the Lifelong 2 project with Katie. And our topic was pneumonic barriers for the contaminant of algal blooms. Here in this photo, right over here, you can see where the bloom is starting in this neighborhood. So Katie talked about the first few slides, so I'm going to go through those, and then I'll do my portion. So the cost of the bubble curtain really depends on the size of the system that you have installed. So it can range from as low as $5,000 to around $70,000, but operating cost or the cost for a deep sea curtain, since it's so much bigger, would be closer or greater than $100,000. The operating costs are very low. They're only between $5 and $500 a month, which makes this both a safer and cheaper option than using chemicals to treat the algae. And there's minimal maintenance involved, so you don't need a lot of labor or anything like that. The only thing that needs to be done is the perforated tubes need to be cleaned periodically to prevent any buildup of mineral deposits, clogging, or clogging of biofuel, things like that. We have a YouTube video here that explains the bubble curtain more in depth, but it will not play on the Zoom for some reason. Okay, so next we looked at how this relates to fluid mechanics. First, we looked at the Archimedes principle, and this states that an object submerged in a fluid experiences an upward and buoyant force equal to the weight of the displaced fluid. In this case, the buoyant force determines the velocity at which the bubbles rise to the surface, which affects both the flow and the size of the bubbles. And an equation to look at the buoyant force would be the force equals the density of the water times gravity times the volume of the bubble. Next, we looked at the Reynolds number, and the Reynolds number is a subject's tendency to resist change in motion. So flow can either be turbulent, which is a continuous mixing of the layers of water, or laminar, which is a smoother and there's no mixing of layers. Smaller or no bubbles means a laminar flow and a low Reynolds number. But with the bubble curtain, we can create larger bubbles, which are more turbulent. The larger, the better, since it's going to create that distribution in the water and cause that algae to break up. Next, we looked at the viscosity. And viscosity is the measure of a fluid's ability to resist flow. This affects the drag force on the rising bubbles. So a higher viscosity slows the speed at which the bubbles rise, which affects the turbulence created by the curtain. And then lastly, we looked at a little more in depth of how the bubble curtain really does affect the flow. So an increase of turbulence, as I said previously, disrupts the laminar flow and promotes a mixing of the layers of water, causing both horizontal and vertical motion. These two types of motion really cause that algae to break up. This also causes a decrease in wave energy and maintains a more stable flow near the curtain, which is super important. And then these two photos here on the right, the top one just depicts a pretty good graphic of what the bubble curtain looks like in action on the bottom of the water floor. You can see almost like little lines of the bubbles going up and rising to the surface, and they're getting pretty big as they go up there. And then another added benefit of the bubble curtains is that it's actually really good for animals. It helps drown out, if you would, the noise pollution from boats, cranes, wind turbines, things like that, because all of this noise pollution can really affect the way that animals like dolphins and whales kind of speak to one another. So this just creates more of an ambient noise, and it's really beneficial for all sorts of things. So the bubble curtain is definitely really effective and is actually in use right here in South Florida, as we have pretty big issues with algal blooms. We think that the bubble curtain is a great solution, and it's also a great representative of fluid mechanics. So thank you.